Hello, remote learners. Congratulations on making it this far on your journey to subtraction with understanding. I hope you're beginning to feel very comfortable with the big ideas of difference and distance. If you are, I bet you're becoming more confident than ever with your subtraction facts and starting to see how you can use subtraction to solve a whole lot of real-world problems. However, our mastery of distance and subtraction is only as strong as our mental number line. So let's make sure that that mental number line is as strong as steel. Here we have a 0 to 20 open number line. So what numbers do we need to add to this number line to complete it? Well, we need to add 1, 2, 3, 4, 5, all the way up to 20. So how could we do that? What would be a good strategy for completing this number line? Well, one thing that we could do would be to just start counting and add the hash marks. So we could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Does anybody see a problem? That didn't turn out to be a very good strategy. We know that in order to be a number line, the distance between each pair of number neighbors must be exactly 1, or if we're drawing it freehand like this, pretty close to 1. Can you think of a better strategy for completing this number line? Pause the video and think about it. If you're working with someone, talk about it. Did you figure out a good strategy for completing this number line? Well, one thing that's always wise to do when we're working with open number lines is to use our midpoints. The midpoints are points that are right in the middle of two numbers that we already know. So in this case, the numbers we already know are 0 and 20. What would be right in the middle of 0 and 20? Right exactly halfway between 0 and 20. That's right, it would be 10. So all we have to do is figure out where is the middle of this number line, and that will be 10. Where do you think it would be? I think it would be maybe right around here. What do you think? Does that look right? Is that the middle? All right, let's try it. Let's put a hash mark there. Okay, now let's see how we did. Oh, we did pretty good. We didn't get it exactly in the exact right spot, but we were very, very close. So that was a pretty good estimate of where 10 would be on this number line. Okay, now that we've found and labeled 10, what other midpoints can we add to our number line? I'll give you a hint. This should give us two new midpoints. Do you know what they are? If you need to pause the video to think about it, do that now. So now that we have 10 on our number line, we have a midpoint that's between 0 and 10, and another midpoint that's between 10 and 20. So first, let's see if we can find this midpoint that's between 0 and 10. I think it would be right about here. What do you think? Right about here? All right, let's put a hash mark. That's not a great hash mark, but that's okay. And then let's see if we can find the midpoint between 10 and 20. Maybe right here? What do you think? Let's try right here. All right, there's a hash mark. So what would these midpoints be? Well, this midpoint is halfway between 0 and 10, so that should be 5. And this midpoint over here is halfway between 10 and 20, so that should be 15, 10 and 5. So let's see how accurate we were. Oh, we were pretty accurate. We weren't exactly in the middle, but we were very, very close. Okay, so we've used midpoints to find and label 5, 10, and 15. Now things get a little bit tricky. Do you know why things get a little bit tricky now? Well, it's because we can't use midpoints anymore. Let me ask you this question. What number is exactly halfway between 0 and 5? What number is exactly halfway between 0 and 5? Well, there is no whole number or natural number that's exactly halfway between 0 and 5. So we can't use midpoints anymore. We need another strategy. Well, what are the numbers that go between 0 and 5 on the number line? We would need 1, 2, 3, and 4. That's 4 numbers. 1, 2, 3, and 4. That's 4 numbers that we need to put between 0 and 5. So that means that 2 of those numbers, 1 and 2, are going to be over on this side of the number line. They're going to be closer to 0 than they are to 5. And the other 2 numbers, 3 and 4, are going to be on this side of the number line. They're going to be closer to 5 than they are to 0. So we need to just make an estimate. Okay, so I'm going to put a hash mark here and a hash mark here. Those are my 2 numbers that are closer to 0 than they are to 5. Now I need 2 numbers that are going to be closer to 5 than they are to 0, and I want to try to make all these the same size. So I'm going to put a hash mark about here and about here. Okay, so this number would be 1, this number would be 2, this number would be 3, this number would be 4, and then 5. So how accurate do you think my estimates of 1, 2, 3, 4, and 5 are? Well, looking at them, I don't think they're going to be exactly accurate. I think I may have made my 1 a little bit too big. But let's check. Yeah, I did make my 1 a little bit too big. My 4 is very, very close, but my 1 was a little bit too big. But that's okay. We're practicing. We're building up our mental number line and making it stronger. Okay, so I'm going to use the same strategy for the part of the number line that's between 5 and 10. I know there are going to be 2 numbers that are closer to 5 than they are to 10. That's going to be 6 and 7. And then 2 numbers that are closer to 10 than they are to 5. That's going to be 8 and 9. I also know that last time I made my 1 a little bit too big, so I'm going to try not to make my 6 a little bit too big. I'm going to try to make it more accurate. So I'm going to put my hash mark here for 6, 7, 8, and 9. All right. How accurate do you think my estimates are? Well, let's check. This time, my estimate for 6 was very accurate, but then I started to get a little bit too small, so that my estimate for 9 is farther away from 10 than it should be. 9 should be a little closer to 10 than where I put it. Okay, that's all right. I'm going to keep learning. Now I'm going to look at the section of the number line between 10 and 15. So the 2 numbers that are closer to 10 are going to be 11 and 12. And then the 2 numbers that are closer to 15 are going to be 13 and 14. So I'm going to look at the numbers we already have on here. And I'm going to put 11 right about here. And I'm going to put 12 right about here. And I'm going to put 13 right about there. And 14 right there. Okay, let's check to see how accurate my estimates were. Whoa! Those were some accurate estimates. I estimated 11, 12, and 13 pretty much exactly in the correct place, the correct location, and 14 maybe is just very slightly off, but it's very, very close. So this is what we're going for. We want to practice until we can complete the 0 to 20 number line with very accurate estimates. That's when we know that our mental number line is as strong as steel. Now let's give our math brains a real workout by modeling some making 10 subtraction problems on open number lines. You can use the activity sheet to follow along with the video, but you don't really need it. You can actually just draw your own open number line for each problem. Okay, let's get started. Okay, our first problem is 12 minus 9. I know that 12 minus 9 means the distance from 9 to 12. So what's the first number I should find on my open number line? Well, the first number I need to find is 9. And I know that 9 is right next to 10. So I'm going to put my hash mark pretty much right next to 10. And the distance from 9 to 10 is 1. And I know that 12 is 2 bigger than 10 because 12 means 10 and 2. So if that's 1 bigger, that would be 11. And 2 bigger, I don't know if that's quite big enough. Let's go a little bit further. 2 bigger would be 12. So let's put 12 right here. And the distance from 10 to 12 equals 2. So the distance from 9 to 12 equals 1 plus 2, which is 3. So we've modeled 12 minus 9 on an open number line. Now let's check it. Okay, our estimate for 9 was pretty good, and that is a distance of 1. Oh, our estimate for 12 was pretty accurate as well, and that is a distance of 2. So that means the distance between 12 and 9 is 1 plus 2, or 3. So it checks out. Our model was pretty accurate. Okay, here we have 11 minus 7, which is the distance from 7 to 11. So I first need to find 7 on my number line. I'm going to use the midpoint, which is right about here. That would be 5. Halfway between 0 and 10 would be 5. And then I need 7 to be closer to 5 than to 10, but kind of in the middle. So I'm going to put it right about here. And the distance from 7 to 10 is 3. Now I need to find 11. I know that's right next to 10. So I'm going to put that there. The distance from 10 to 11 is 1. So the distance from 7 to 11 equals 3 plus 1, which is 4. Okay, let's check to see how accurate our model is. 7 is pretty accurate, not too bad, and that is a distance of 3. Our estimate for 11 was a little too big, but that's not bad, it's reasonable. And the distance from 7 to 11 is 3 plus 1, which is 4. Okay. Now we have 13 minus 8, which is the distance between 8 and 13. So first I have to find 8. I'm going to use the midpoint between 0 and 10, which I think is right about there. That would be 5. Now I need to find 8, which I know is going to be kind of in the middle between 5 and 10, but it's going to be a little closer to 10 than to 5. So I'm going to put 8 right about there. And the distance from 8 to 10 is 2. Now I need to find 13. So I'm going to use the midpoint between 10 and 20, which I think is right about here. That would be 15. Now, just like I know that 3 is a little bit closer to 5 than it is to 0, I also know that 13 is going to be a little bit closer to 15 than it is to 10. So I need to find 13. I'm going to put it right about here. Try that. So the distance from 10 to 13 would be 3. That means that the distance from 8 to 13 equals 2 plus 3, which is 5. Okay, let's check it out, see how accurate our model is. So 8 is pretty accurate, certainly reasonable, and that is a distance of 2 from 8 to 10. Oh, 13 was very accurate, and that is a distance of 3 from 10 to 13. So that means that 13 minus 8 equals 2 plus 3, which is 5. So how are you feeling? Are you getting the hang of it? Are you starting to become comfortable with modeling making 10 subtraction on an open number line? Being able to model anything in math on a number line is a sure sign of mastery. It's not easy though, so keep practicing. Here we have 11 minus 9. This should be a pretty easy one. Pause the video and see if you can model 11 minus 9 by yourself. How did your model turn out? Well, let's see. 11 minus 9 means the distance from 9 to 11. I know that 9 is right next to 10 and a little bit smaller, so I'm going to put it right here. And 11 is also right next to 10, but a little bit bigger. So I'm going to put it right here. The distance from 9 to 10 is 1. The distance from 10 to 11 is 1. So the distance between 9 and 11 equals 1 plus 1, which is 2. So let's see how accurate this model is. Well, my 9 isn't quite as close to 10 as it should be, but it's okay. It's a reasonable estimate of 9. And my 11 is a little bit further away from 10 than it should be, but it's okay. It's a reasonable estimate of 11. And those distances are both 1, so that means that 11 minus 9 equals 1 plus 1, or 2. So this model wasn't perfect, but it doesn't have to be perfect. It just has to be reasonably accurate. Okay, pause the video again and see if you can model 11 minus 6 using making 10 subtraction on the open number line. So the first number I need to find is 6. I'm going to use my midpoint between 0 and 10. That would be 5. And I know that 6 is right next to 5, just a little bit bigger. So I'm going to put it right here. The distance from 6 to 10 is going to be 4. Now I need to find 11. I know that's right next to 10, so I'm going to put it right here. The distance from 10 to 11 is 1. That means that 11 minus 6 equals 4 plus 1, which is 5. Okay, let's see how accurate this model is. My 6 should have been a little bit closer to 10, but it's a reasonable estimate, and that shows that the distance from 6 to 10 is 4. And my estimate of 11 was pretty close, definitely reasonable, and it shows that the distance from 10 to 11 is 1. So 11 minus 6 equals 4 plus 1, which is 5. Okay, mathematician, your powers are growing. You are on the verge of becoming a true master of the subtraction universe. I'm going to let you continue practicing on your own. Pause the video, model the problem, and then check it. I'll talk with you again at the end of the video. Were you able to model all of the distances that cross 10 on an open number line? If so, congratulations! You are definitely and officially a master of the subtraction universe. So it's time for a celebration. Have a cupcake, a cup of apple juice, demand subservience from your siblings. Do something, just celebrate.